Okay, and welcome. So let's try to talk about a little bit of algebra. This is McCollum's math because it probably doesn't have all the formulas and stuff that you need. But most of the time, if you see an equation where you see something like, well, there's a plus sign, and there's a 3, and it equals, we know what equals is, an 11. We understand most of that. We would just expect to have the other number right here, right? Instead, it looks like what we have is some sort of blank. And that's what algebra really is we end up putting something in to try to figure out what might be the missing thing. So we substitute in for an unknown a letter. And so they might choose X, they could choose A, B, C, any of the alphabet, but they put something in so we say we don't know what that is. And so you could even say X equals question mark because we don't know, right? And then there's a lot of ways to solve this. You could try random trial and error. So if we know that it's plus 3 equals 11, we could just pick a random number. I'm going to put 6. 6 plus 3 is equal to, let me add that together, use all my fingers, 9. So that's not enough, right? And so then I could say, well, it's close to 11. Let's just do another one, 8. 8 plus 3 is equal to, 11. Look, that's what that is. So that must be what X is equal to. So now I can go back and I can erase that question mark and say that X is equal to 8 because 8's what works there. The thing is, trial and error could take forever, especially if it's more complicated than this, because let's be honest, this is an easy addition problem. Hopefully you knew all of that, right? So instead of doing it that way, we just solve for X. So let me show you how you would do that. So instead, if I had that X plus 3 equals 11, then all we're going to do is we're going to move everything that we can to the other side. We want letters on one side, and when I say sides, I'm talking about of that equal sign. We say that's the gate. And so I want numbers on one side, letters on another side. And so I have to do the opposite operation, which is just whatever plus, minus, divide, multiply is. So where I have plus 3, I'm going to subtract 3. And what I do on one side of the gate, I have to do on the other side of the gate. So if I subtract 3 from there to get rid of that 3, I have to subtract 3 on that side. So 3 minus 3 is 0, right? Gets rid of that. And then I could do 11 minus 3 is going to be 8. Well, I bring my equal sign down. All I have on that one side is an x. X equals 8. And I solved it algebraically. It's not that much more difficult when you start to look at it in the grand scheme of things. It's just you got to learn your order of operations. You remember order of operation, right? I always memorized it as an anagram. Please excuse my dear Aunt Sally. But you use that just to remember the first letter, and all of these stand for something. What do they stand for? Well, this is what it stands for. P, parentheses. E, exponents. M, multiplication. D, division. A, addition. S, subtraction. And really, if you just work on going down this list, so starting from the top, going downward, and that's the order you need to do things. You do need to remember that basically those two and those two are kind of paired. Multiply and division, they're about equal power. Addition and subtraction, they're about equal power. And so we'll look at that just more here in a second. But if you get this basic understanding, to do algebra, you're basically going to be doing the same thing, but in reverse, okay? Because you're trying to undo it. So undo, usually start at the end and work your way up, right? And we're going to see how that applies to some things. So let's say we had an equation that looked more like this. 20 is equal to x minus 3 all divided by 2. Now, this is how things might appear, especially when we start working it with science. The problem is you need to understand a couple of things about this. First of all, you need to understand that anytime you have stuff like this, where it's multiple things being divided by one thing, it's really like saying, hey, I have a parentheses on the top of that. And so if we're looking at things, we notice up here that parentheses are the last thing we're really going to deal with in getting that. And so the first thing we're going to have to do is we're going to have to deal with that 2, right? Because dividing comes after parentheses. So if we're working our way back up, we hit division first. Now, you always use the opposite thing. So the very first thing I'm going to do is I'm going to multiply both sides by 2. Because remember, what I do to one side of the equal sign, I have to do to the other. In fact, we can draw a little straight line down for that equal sign. Okay? Now, if I do something that's multiplied and divided by 2, they're just going to cancel each other out. Okay? Opposite function, it cancels each other out. You can just not worry about that. And so down here on this equal sign, I can go ahead and write my parentheses x minus 3. And then I need to do 20 times 2 is 40. Okay, so now I have a new equation because I got rid of that 2. Notice again, I'm just moving the numbers to one side and trying to get this variable or this letter all by itself on the other side. So I now have x minus 3. There's nothing outside the parentheses, so I can just look at what's inside of it, right? And so really it's like there's nothing, no parentheses there anymore. But it was important before, so we knew the order to do it in. So there's my 3. Try to make it not look too janky, but it is. All right, so opposite of subtracting, adding. So I add 3 to that side. Remember, I'd have to add 3 there. Negative 3 plus positive 3, that gets rid of 3 on that side. Meaning if I bring my equal sign down one more time, I now just have x left alone on that side. And then 40 plus 3 is going to give me 43. And that's a true statement. I know that if I go back and I plug in 43 for that x up there, I'm going to get 20. In fact, let's do that. So here's that same problem just written out. 43 minus 3, that's going to be a 40. 40 divided by 2, that's going to give me 20. So you can see plugging it back in, that's a true statement. So we even double checked to make sure that it worked. And it's just doing those order of operations. It could be much more complicated than that if you want. But it's just going to be the same thing. You start towards the bottom of this subtract addition, and you work your way back up to get all of the letters on one side and all the numbers on another side. Now, here's the thing where it gets a little bit different with science. So that variable we were talking about that we use as an x, a lot of times it's not used as x. We're going to say, let's look at speed for a second. So speed is represented with just an s. And we say it has a mathematical relationship between distance and time. So all 3 of those are variables. But if you have a problem that says, like they were going 20 miles per hour for 2 hours, and then it wants you to find the distance, right? Well, that means that they gave you number values to put in for your time and for your speed. So you can rewrite that entire equation to where it only has one variable. You can now write it as 20 miles per hour is equal to d divided by 2 hours, right? Now that you have only one variable, that d on top, you can algebraically solve for that the same as we did before. And so I can say times 2 hours on this side. It's going to cancel it out there. But remember, what I do on one side, I have to do the other. So So I'm going to have to multiply by 2 hours over here. And what I'm going to get is I'm going to get that this is 40 miles, because that cancels out the hours even on that side there, is equal to d. And we would have that distance. So it's still algebra, it's just with science, we actually understand what all these random letters stand for so that we can helpfully put in more numbers to help us solve things. And that's all there is to it.